Hello friends, welcome to my channel. So today we are going to discuss a problem, quantum chemistry problem from GATE 2020. It's a two marker net type questions and uh, it takes uh, too long time to solve. Uh, let's see how can we approach this problem. See, what is the question? The question is the percent error in the ground state energy of a particle in a one-dimensional box of length a described by a trial variation function which is phi is equal to x into a minus x, where x lies between 0 to a, and the true ground state energy is given. See, just a second. And the true ground state energy is given, and also the normalization factor is also given. Let's see, this is the problem for variation from variation theorem. How can we calculate the energy of a trial function? See, it is a problem of 1D box, one dimensional box is a problem of 1D box. So how can we calculate the energy of a trial function? See, what is the formula? So E trial, energy of a trial function, E trial is equal to, here the function is in phi, so phi to Hamiltonian. I am using the bracket notation. If you are familiar with the integral formula, you can do that. Divided by bra in phi in bra and phi in ket. Here, this is the formula for energy of to calculate the energy of a function, trial wave function. See, and this is the function and this is the Hamiltonian. What is the Hamiltonian for one dimensional box? The Hamiltonian for one dimensional box is equal to, the Hamiltonian for one dimensional box is equal to minus h cut square by 2m into del square by del x square plus Vx. Here you see, here we are talking about the particle in a box. So in a box where the particle always moves, the potential energy is going to be 0. So easily we can eliminate the potential energy part. So now in this problem we are only talking about, or we are taking the consideration of the kinetic energy. Okay, so now our task is to solve. Here see, this is the function which on phi c, this part we can write as integral phi star phi into d tau. Here we are talking about the x lies between 0 to a, so the limit is 0 to a. So this value, the normalization value, is given here. Okay, so this is not our business for now, so we can erase this. Okay, just a second. Now our task is to solve this part. Okay, so what is this part? Just a second. Introduced ball pen. Okay, here you see what is the integral. The integral is for this part. For this part, the integral is 0 to a phi star Hamiltonian into phi into d tau. Okay, so here what is phi star? This is phi. In, so phi star is also the same thing. So 0 to a, we can multiply this x a minus x square. What is the Hamiltonian? 2 minus h cut square upon 2m into del square by, so del square upon del x square, and here the phi, what is the phi? The phi is x a minus x square, and here you see the detail is nothing but here is dx, because we are talking about one dimensional box. See, how can we solve this integral? See, this is a constant, so it turns out, so this is h cut square upon 2m into 0 to a x a minus x square. After that, see, what is this integral? Del square upon del x square into xa minus x square. What is this derivative? Not integral, what is this derivative? It will say if we are trying to solve this derivative, then we get, see, at first ddx and ddx, we split it out, dx and ddx into xa minus x square. Okay, so what is this? See, if we are trying to solve ddx or upon the function x into a, see, you can figure it out at xv uv formula, but you see the first term comes x into dA by dx. So dA by dx is nothing but 0 because there is a constant value. So dA by dx is nothing but 0. And what about the other term? The other term is a into dx by x. So here for first integral, the first factor, the first function comes as a. The first factor comes as a. And what about the second? The second function comes as, so here you write ddx is equal to a minus minus 2x. And after that, if we perform the second derivative, then it comes, it is a constant, so it comes as 0, and here the minus 2 comes out. And what about ddx? The ddx is nothing but 1, so this integral comes as minus 2. Okay, so let me erase this because we have not enough space to solve. These things is not required to solve in pen and paper. You can, if you are smart enough, then you can solve with your mind, not using pen and paper. So here see, what comes, uh, this comes as minus 2, this integral comes as minus 2, this derivative comes as minus 2, then dx. So minus 2 is a constant, so it comes out, and minus into minus plus, and 2 and 2 cancel out, so here it is comes h cut square upon m 0 to a upon x a minus x square into dx. After that, see, what is this? This is xa, so a comes out, and what is about x? So h cut square upon m into, here you see a comes out, and if x dx, what about x dx? X dx is nothing but x square by 2. So if we put the value of a, then a square by 2. So a square by 2 into a, that is a cube upon 2 minus, What about x square? X square is nothing but x cube by 3 if we perform integration x cube by 3. And what is x? X is nothing but a. Because the lower limit is 0, so that is nothing but a cube by 3. So this comes as, here you see h cut square a cube by 6, sorry, not 6, that is 3. Okay, it's my mistake, that is 3, that is 3. So it comes as h cut square into a cube upon 6 into m. Okay, so this is the integral of this part, this is the value of this part. And let me erase all the things, erase these things, the integral part, because we have not enough space to solve. Okay, just a second. So what about this term? This term is comes as this, this term is comes as this. And what about this part? This part is given. So what about e trial? So now e trial is equal to h cut square upon into a cube upon 6m. And for this part, that is 30 upon a to the power 5 if we multiply this. So 30 into 6 cancel out, this comes as 5, and this comes as a square. And if we are trying to make h cut square in a terms of h cut in terms of h, so as we know h cut equal to h by 2 pi, because here the for the actual value here it is h, so that's why we're trying to make this. So now it comes 5 h square upon 4 pi square m a square. Okay, so this is the value of e trial. Now what is the value of e actual? This is the value of e actual, this is the value of e actual. So now how we can calculate the percentage error? So the percent error is equal to e trial minus e actual upon e actual into 100, because of percent error into 100. Okay, so now if we are trying to solve this, see what is e trial, this is e trial, what is e actual, this is e actual. So this comes as, here you see h square upon m square takes as common, so h squares upon m square into 5, so you can do 4m square as common, 5 upon pi square minus half upon, for the actual, h squared upon 8m square into 100. Okay, so now h square can cancel out, am can cancel out, a square can cancel out, 4 and 8 comes as 2. So what is this value? So this value comes as the percentage error is equal to 5 upon pi square minus half into 2 into 100. If we put all the value, it comes as 1.42. So the correct answer is 1.42. Okay friends, thank you for watching. If you want this is help, if you like this is helpful, please like, share and subscribe my channel.